So in this video we'll be going through all the types of decimal numbers you can have and showing you how to convert decimals into fractions and fractions into decimals. So decimals converting to and from fractions. So fractions decimal percentage, also known as FDPs, are different ways of representing proportion, and each can be written in the form of the other. Now in basic maths, being able to convert 80 FDPs to each other is not only an expected and key area of number to master, but at any level it's an important skill as it has so many links into many other topics in maths. Now moving forward onto decimals, now there are three types of decimals that you need to be aware of. Terminating, reoccurring and non-terminating, and each of those three things are quite self-explanatory based on its title. So if we start with terminating decimals, now terminating decimal is basically a number that ends. So for example, 2 is a terminating decimal. 2.34 is a terminating decimal. Any numbers where it finishes, it stops, there's no numbers after a particular number is a terminating decimal. So 2.14615 is a terminating decimal because there are no numbers that follow after the 5, that's where it stops. Now a reoccurring decimal is one where it's got a little pattern. So this does go on forever, it doesn't really stop, although your calculator may say otherwise, but it's a sort of number that follows a sort of pattern. So for example, if I had 2.33333 and that went on forever, now because it goes on forever it's a reoccurring decimal, but because 3 is a sort of pattern that always starts, that it continues with that number, that's basically why it's reoccurring. And obviously another way of writing this is 2.3 with a little dot. So any number that's being repeated has a little dot there, just represent that it's that number continued. Also reoccurring decimal can look like this, so you can have more than reoccurring, so you can have 314, 314, 314, in which you'd have a dot where the pattern starts and the second dot where the pattern finishes. You can also get reoccurring decimals that look like 2.34444, and that continues, in which that can be written as 2.34 with a little dot on top. And you can also have ones where you've got 0.719344719 934, and that continues. So again, I can write it as such. Now you don't have to write out the pattern twice or 3 times. You can simply just write the pattern once. If I just get rid of that second repeat and just have a dot on the 7 and a dot on the 4, that would be absolutely fine. Now you can also, with more modern scientific calculators, there are buttons where you can input reoccurring decimals into your calculator. If you look out for a button that's got a little box and a little dot on top, then all you need to do is type in. So for example, if I was going to type in this number here, I would enter 0 point and then I'd press this button on your calculator, press the 7, 1, 9, 3, and then press the button again and then to the 4, and it should look exactly like it does here. Now with a calculator, reoccurring decimals usually end because your calculator can only display a certain amount of numbers. So for example, if I was going to have 7.3, let's say 555, and that was being reoccurring, then what my calculator would show is 7.3555555 and then 6. So what it would do is it'd round up the very last digit, because obviously calculators can only really roughly show about 8 or 9 characters. Now for a non-terminating decimal, now this one's going to be quite difficult for you to write as a fraction, but non-terminating is just like that. It doesn't follow, it continues forever, and it doesn't follow a particular pattern. Now terminating decimals would look like if you had root 2 or root 3 even. You can even have numbers like pi, which doesn't follow a particular pattern, but it's a decimal number that goes on forever. So whenever you're working with decimals, it's important that you recognise what type of decimal it's going to be. Now the other thing that's worth knowing in terms of names, worth introducing here, is that each of these, so terminating, if a number is classed as a terminating decimal, then it is classed as a rational number. A reoccurring decimal is also rational, because basically a rational number is any number that can be written as a fraction, and a non-terminating is usually going to be an irrational number. So moving on to how we convert decimals into fractions and vice versa. So to converting fractions to decimals, I follow two simple steps that I generally recommend and use myself. Obviously there are different ways in which you might do it, so as long as you get the right answer, that's all that matters. So let's start with some examples, and I'll recall these steps if it doesn't make too sense of how we actually use them. So for number one, let's say we want to convert, let's go for 3/8 as a decimal. So we want to convert 3/8 into a decimal. So the first thing we want to do is set up the bus stop as a way of division. So your denominator goes outside the bus stop, and your numerator goes inside. Now the reason for this is because we want to work out how many 8's go into 3, and so 8 goes outside, 3 goes inside. Now from this on its face value, we know that 8 doesn't go into 3, so it's definitely going to end up with a 0-point number. Now one thing that's worth bearing in mind is that when you've got a proper fraction where your numerator is smaller than your denominator, your number is always going to be 0 point something. So here 8's don't go into 3, so we write a 0. And from this, now typically you might end up writing a remainder of 3, but when you're converting decimals, we don't write any of this remainder stuff. Instead, what we do is we add zeros. So here I'm going to have a 0 and I'm going to carry the 3. So now I'm working out how many 8's go into 30. Well, that would be 3 with a remainder of 6. And I'm just going to carry on. So how many 8's go into 60? That would be 7, remainder 4. Add a 0, and then I've got a 5. So here the correct answer is going to be 0.375. And there you go, because now that I've got no remainder, that's where it stops. Now for our second example, let's go for 3 over, let's go for 7. So again, I'm going to have 7 outside the bus stop and a 3 inside the bus stop. Well, let's change it. Let's change it to an 8. Let's change that to an 8. So here, what we're going to do is going to see how many 7's go into 8. So again, here we've got 7 goes into 8 once. And as I've got a remainder, I've got a remainder of 1. And then how many 7's go into 10? That would be 1 with a remainder of 3. How many 7's go into 30? That would be 4, remainder 2. How many 7's go into 20? That would be 2, remainder 6. How many 7's go into 60? That would be 8, remainder 4. How many 8's go into 40? How many 7's go into 40 rather? That would be 5, remainder 5. How many 7's go into 50? That would be 7, remainder 1. How many 7's go into 10? That would be 1, remainder 3. And as you can see, that from this, now when I've got 1 and a 3, that's bringing it back to this, in which the next number is going to be a 4. The next number then is going to be a 2, 8, 5, 7, and so on. So the answer to this particular conversion is going to be 1.142857 with a dot on this 1 and a dot on the 7. Let's go for another third example. Let's go for a long multiplication. Let's go for 12 over 7 again. So here we've got an improper fraction again. So here I'm going to have how many 7's go into 12, like so. Now here it's always worth bearing in mind just checking to see, can you simplify this fraction? So let's just for argument's sake, if I had 12 over, let's say 10, then I could simplify this as 6 over 5. And so what you're working with is the same sort of fraction, and you'll get the same answer, but it's working with smaller numbers, and smaller numbers are definitely a lot easier for you to work with. So here we're going 7 into 12. Now if you want to have a go at working this one out, you can do, in which you should have the answer of 1.714287 with those two recurring. So going through the steps now, again it's important that one, you don't have remainders, instead you just keep writing the zeros until you spot a pattern. If you find that there is no pattern, just try and persist. Sometimes, particularly in exams, it might be a long process, for example, like number 2 and 3, where you might be doing it a couple of steps, let's say like 7 or 8 times before you spot a pattern. But that's the whole purpose of this, and speed will obviously make it a lot quicker. But the more practice you have, the speed will be make it easier for you to do. So then converting decimals into fractions. Now this can be done in several steps. So I've wrote down the steps on this, you can see on the screen, and let's go through some examples of what they all mean. So for number 1, let's say I want to write, let's go for 0.31 as a decimal, as a fraction, sorry. So for this, what we're going to do is follow the 3 steps. So for this, I'm going to ignore the 0 and the decimal point and write down what numbers I've got. So I've got 0, 3, 1. I'm going to ignore the 0, so I've got 31 as my numerator. Now for the second one, for the denominator rather, I've got a 1. Now as you can see, I've got 2 numbers after the decimal point. So what I then do is add 2 zeros, and then I just check to see, can I simplify 31 over 100? No, I can't, because 31 is prime, so there is your final answer. So if I had another decimal number, let's go for 232, let's say 0.32 if we've got a decimal, then what this would then become is 232 over 1, and I've got 1, 2, 3 numbers after the decimal point, so it's going to be 3 zeros, so that's 232 over 1000, which simplifies to be 29 over 125. Now if I had, let's say, 14 point, let's go for 8, and we want to write that as a decimal, as a fraction rather, so here I'd write, ignoring the decimal point, I've got 148 over, I write the 1, and I've only got one number after the decimal point, so it's going to be 148 divided by 10, which simplifies to give me 74 over 5. And again, you can write that as a mixed number if you want to need to, or whether you just want to test your skills, which gives us 14 and 4/5. So again, for our last example, let's go for 3.024. So again, ignoring any decimal point, I've got 3024 over 1, and I've got 1, 2, 3 numbers after the 0 decimal points. I've got over 1000, and 3024 divided by 1000 simplifies to give me 378 over 125, and again, converting that into a mixed number, we get 3 and 3, 125. The last example, let's just go for one where we've got a few zeros, so let's go for 219. So here, as you can see, I'm going to write this number ignoring any zeros and the decimal point, in which I get 219. I write a 1, and I'm going to count how many numbers I've got after the decimal points. I've got 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And there is your final answer. I'm just going to double check to make sure that that doesn't simplify, which it doesn't. And so there is our final answer. So here is a few for you to have a go at. And if you just want to pause the video, and then I'll go through the answers. So for the answer you should have, so for number 1, here you should have 0.5 recurring, so 0.5555, and it carries on. For question 2, you should have 2.6 recurring, so 2.66666, and that continues. For number 3, you should have 20.375. For question 4, you should have 1.083 recurring. For question 1 on here, you should have, so it'd be 238 over 1000, which does simplify to give you 119 over 500. For question 2, you should have 1245 over 100. Let's go with that. which does simplify to give you 249 over 20. For question 3, you should have 6347 over 1000, which doesn't simplify. And finally for question 4, you should have 96 over 1000, which does simplify to give you 6 over 625.